In this video, we will learn about monotonic sequence, and in next class, we will learn about the monotone convergence theorem. So, to know the monotone convergence theorem, we have to have idea about monotonic sequence. So, to have idea about monotonic sequence, we have an idea about increasing and decreasing sequence. So, what is increasing and decreasing sequence? So, a sequence xn is said to be so here n varies from 1 to infinity. Sometimes we write it, sometimes not. So is said to be increasing if xn plus 1 more or equals to xn for all n more or equals to 1. So next term would be more or equals to the previous term. For example, if we consider n square where n varies from 1 to infinity, and here xn is n square, xn equals to n square. So n varies from 1 to infinity. So when n equals to 1, so 1 square means 1. When n equals to 2, so 2 square means 4. When n equals to 3, it's 9. When n equals to 4, then it is 16, and it's keep going on because this is an infinite sequence. Now if you look this one graphically, so here this is n, this is n axis, and here this one n square. So n varies from when n is 1, so here n equals to 1, so here n equals to 2, here n equals to 3, n equals to 4, and it keeps going on, and here it is n equals to 0. Now when n equals to 1, then we have 1. So if you think this is 1, when n equals to 2, then we have 4. Suppose here 4, so 4 is here 1. When n is 3, it's 9. Suppose it's 9 here, so here 9, and when n is 4, then we have 16. So suppose 16 is here, so 16 is here. So if you add those, you will get an increasing graph. Yeah, this type of graph. So at this point, here n is 1, n is 4, 9, and here n is 16. So this is an increasing sequence. And how about decreasing sequence? Now a sequence xn is said to be decreasing if xn plus 1 less or equals to xn. That means next term would be less or equals to the previous term for all n more or equals to 1. For example, if we consider this one 1 over 2 to the power n, so consider this one 1 over 2 to the power n. So here xn is 1 over 2 to the power n, and n varies from 1 to infinity. So n varies from 1 to infinity. So when n is 1, then it is 1 over 2. When n is 2, it is 1 over 4. When n is 3, it is 1 over 2 to the power 3, so it's 8. And when n is 4, so 2 to the power 4 means 1 over 16, and it keeps going on. So did you see, if you compare any consecutive two terms, so next term is less than the previous term. So 1 over 4 means 0.25, and this one is 1 over 2 means 0.50. So this one definitely less than that one. Similarly, 1 over 8 is 0.125, definitely less than 0.25. So next term is less than previous term. Okay. And if you plot it graphs, then you can see a decreasing function. So this is not x-axis, this is n, and this way will go 1 over 2 to the power n. So when n is 1, here n equals to 1, n equals to 2, n equals to 3, n equals to 4. Suppose when n equals to 1, then this is 1/2, okay, this is 1/2, and when n equals to 2, so it is, suppose it's here 1 over 4, 1 over 4, 1 over 4. When n equals to 3, 1 over 8 here, and when n is 4, it is 1 over 16 here. So if you add those points, you will get a decreasing function. Decreasing graph, you can say. So we learned about increasing and decreasing sequence. Now a sequence will called monotonic if it is either increasing or it is decreasing. If it is increasing or decreasing, then it's called monotonic sequence. So the definition is, monotonic sequence, so a sequence xn is said to be monotonic if it is either increasing or decreasing. Okay. So here we give two examples, and this is monotonic definitely because it's increasing. This is also monotonic because it is decreasing. So both this one and that one are monotonic sequence. So example, so if you can write that one, n square, n equals to 1 to infinity, this is monotonic. You can write 1 over 2 to the power n, this is monotonic. We are ignoring this part. Now see, you can write if negative 1 to the power n or negative 1 to the power n over n, if we consider this one, so when n is 1, so it is negative 1. When n is 2, it is 1 over 2. When n is 3, it is negative 1 over 3. When n is 4, it is 1 over 4, and it keeps going on. Now if you consider those two terms, So which one is bigger? Next one is bigger. So you can think this is increasing, but actually not. If you now compare these two terms, then this one bigger, not that one. So to be increasing function, to be increasing sequence, next term should be bigger than previous one. Next term should be bigger than previous one. Okay, and for decreasing, next term should be less than previous one. Next term should be less than previous one. But here it is not increasing or decreasing. So this is not monotonic sequence. Not monotonic sequence. Why? Because it is not increasing or decreasing. So this is not a monotonic sequence. If we draw the graph, so this is n and this part is -1 to the power n over n. So when n is 1, n equals to 2, n equals to 3, n equals to 4. So when n is 1, this is -1. So here, suppose -1. When n is 2, it is 1 over 2. So it is positive, so it's here. When n is 3, then it is -1 over 3. So it is some places in here. When n is 4, this is 1 over 4. So it is some places in here. So if you join this graph, it is not increasing or decreasing. Okay, this is not increasing or decreasing. So this is not a monotonic sequence. Thanks for watching.